NASA pulled out all of the stops to save the mission. At Marshall, all other work stopped. After the launch, all normal workload on the UNIVAC mainframe computer was preempted in order to support HOSC data processing.
From my somewhat biased perspective, I would say that that 10-day period between May the 15th, when the crew was supposed to launch, May the 25th of '73, when the first crew really did launch, was the most intense, productive, satisfying period that the agency has ever seen.
Throughout the Skylab mission, the HOSC continued to provide engineering support to the 3 successful Saturn 1B launches from pre-launch test until each Saturn S-4B stage was deorbited. Something else happened on Skylab, specifically during the second crew's stay, that is not very well known. But it set the stage for the way that remote operations, or telescience, is done routinely today.
Now, prior to Skylab, there'd only been a single communication link, space crew to Capcom, capsule communicator, at the Johnson Space Center. Even the flight director didn't talk to the crew. If he wanted to tell them to go jump rope, he asked the Capcom, say, tell the crew to jump rope. And that had worked well for years. However, we realized that was a slow process. What the people in space needed was the opportunity to talk with the individual investigator. What do you see? What do you think? How well is this done? What should we do next? And for the first time, and I think I was actually the first person to talk with Dr. Robert McQueen from the High Altitude Observatory in Colorado about his coronagraph experiment. We had, for example, seen an eruptive prominence, a mass ejection move out away from the sun. We could actually measure its speed by looking from one orbit to an hour and a half later come around, see how far it had moved out. We needed to talk about that, see what it was looking to him like, how he interpreted our observations and how things were proceeding. So I think that was the first conversation between crew member and investigator on the ground. It then began to expand to the point where it is now done routinely.
After Skylab came one final Saturn 1B launch for the Apollo-Soyuz test program. The ASTP mission was to demonstrate cooperation between the Russians and the United States space programs and to test a common docking mechanism that would allow spacecraft from the 2 countries to dock and exchange crews in an emergency. The CSM was to be launched on the Saturn 1B and would then rendezvous with a Russian Soyuz spacecraft, and they would dock and the crews would greet each other and then come home.
If the first manned launch of a Saturn V being routed to the moon was ambitious, the first ever launch of a space shuttle with a crew aboard was extraordinarily confident. Still, in the HOSC, where the minute details of the propulsion system were under constant scrutiny, there was simply little margin for error. The support of the HOSC on shuttle launches didn't end with STS-1. NASA managers and engineers involved with the propulsion systems have relied on this support on every shuttle launch since. During the hiatus of manned flights between the completion of Apollo-Soyuz in 1975 and the first shuttle flight in 1981, the HOSC was mothballed and most of the equipment became obsolete. So when the facility was reactivated to support the shuttle, a dedicated data processing system was developed that was independent of the institutional system. The engineering consoles were redesigned. The data system now supported both the legacy 50 kilobits per second data stream from the Launch Control Center and the 192 kilobits per second orbiter downlink. The limited technology of the 1970s that enabled televising digital data was used at the beginning of shuttle support. In the mid-80s, it was replaced by a mini-computer-based system. In the 90s, it was then further evolved to the PC-based system in use today, which provides for ever more effective and economical services.
The HOSC was called on increasingly to support shuttle payloads as well as the shuttle itself. We supported 4
activating
inertial upper stage launches with tracking and data relay satellites.
Round-the-clock engineering support to the Hubble Space Telescope was provided during its launch in the shuttle and throughout the 3-month period of spacecraft and instrument activation.
Several Department of Defense payloads were launched by the shuttle and classified payloads, and so we had to implement a classified data processing capability within the HOSC as well as other security measures.
One of the space shuttle's most frequent flyers was a reusable, highly versatile space station to go called Space Lab. Space Lab, developed jointly by NASA and the European Space Agency, was designed to be a scientific laboratory in space, accommodating a variety of scientific investigations. These investigations were to be operated by both the crew and by principal investigators sending commands from the ground, a first for manned spaceflight. The Space Lab Payload Operations Control Center was initially within the Mission Control Center at Houston. However, the first 3 missions were integrated and managed by Marshall teams using the Houston POC, but utilizing the HOSC for pre-mission preparation and mission support.
The HOSC also provided engineering support for the Space Lab and computer support for the Marshall Integrated Planning System, or MIPS, as well as communication support for the Payload Crew Training Complex. The MIPS was a very sophisticated planning system that did orbit analysis as well as scheduling of all the crew time and experiment activities.
The Payload Crew Training Complex simulated experiments within a ground-based replica of the pressurized Space Lab workshop. The PCTC gave the mission's science crew, like Skylab veteran Owen Garriott, a series of very realistic dress rehearsals. Early HOSC team member Mike Nomchev dealt with budget constraints, this time as he managed the facility's development.
We had mock-ups. We built models of experiments. It looked just like you were inside the Space Lab with a terminal and all that. And then what we did is we would send the data over to the HOSC and also send the data to Houston.
John Young, who had been on the maiden voyage of the space shuttle, was also the skipper of Space Lab 1.
Bob Parker and Owen Garriott would go over to the PCTC and train over there, and we had it integrated with the Mission Control Center, so that when we were doing long simulations, which we ran 2- and 3-day simulations, they would stay over there and operate 24 hours a day, and I would be over here, Brewster and I would be over here working 24 hours a day in our simulator, and it was integrated. So even though we had some switches in our Space Lab trainer over here, the scientific work and all that kind of work was being done over at Marshall with the crew, and they were right in the middle of it. I actually simulated the actual mission and gave us all kinds of failures, and I remember one night they gave me a failure that the main C had failed off, which killed all the power to the Space Lab, and I was over here by myself, and there was 125 steps, a lot of which were A, B, C, D, and F steps, and I had to go through all that to get it back online. It was good training.